The clinical pharmacist in the pediatric ICU is asked to determine what rate to run a child's IV at. The IV contains 9 milliliters of 39.2% potassium acetate in normal saline to prepare a 1 liter bag. The prescriber wants the child to receive 2.5 milliequivalents per hour. Molecular weight of potassium is 39, molecular weight of acetate is 59. What rate in milliliters per hour would provide the desired milliequivalents per hour of potassium acetate? So the first thing I want to do in this question is to convert this here to milliequivalents. That's because they want us to make this in a certain rate in milliliters per hour. But first we want to have milliequivalents per hour because that's the rate they want us to run at, and then we convert it to this milliliters per hour. So to convert to milliequivalents per hour, I'm going to start with this 9 milliliters here and then multiply that by our percent strength here, 39.2%. 39.2% is also 39.2 grams over 100 milliliters. This could also be written as 100 milliliters over 39.2 grams. These two mean the same thing. So the reason why I'm going to use this one here on the left is because I want milliliters here to cancel out the milliliters here. That's why I'm not using this one. And so next I'm going to convert to milligrams so I can use it in the milliequivalence formula. So the milliequivalence formula, so I'm going to convert to milligrams. So 1,000 milligrams in 1 gram. So grams here cancel out grams here. So when you solve for that, you get 3,528 milligrams of potassium acetate. So next I'm going to use my milliequivalence formula. You have to memorize milliequivalence equals milligrams times valence, all divided by molecular weight. So the milligrams is what we just calculated earlier. This is 3,528 milligrams, and times it by the valence of potassium acetate. So potassium acetate is the same thing as CH3 CO2 minus and K plus. So the valence is just 1. See, 1 potassium and 1 acetate. So that's why valence is 1. If you can't memorize this, what potassium acetate is, just memorize. Most people know that potassium is just 1 plus. So obviously the other one has to be minus 1 if potassium is plus 1. So I'm going to divide this by the molecular weight of potassium acetate, which is given here. 39 plus 59 is the molecular weight of potassium acetate. So when you solve for that, you should get 36 milliequivalents. So this here, 9 milliliters of 39.2% potassium acetate. That's 36 milliequivalents. And they say that's in a 1 liter bag. So this is in a 1 liter bag. So 1 liter is the same thing as 1,000 milliliters. So I'm just going to put this conversion factor of 36 milliequivalents for every 1,000 milliliters. You'll see why I use that later. So next I'm going to convert this 2.5 milliequivalents per hour. So this is the rate that the question wants. And then I'm going to convert this to milliliters per hour here. So I start off with 2.5 milliequivalents per hour. I'll multiply it by our conversion factor that we just calculated, 36 milliequivalents for every 1,000 milliliters. But I'm gonna reverse the numerator and denominator because I want milliequivalents in the denominator here, so I could cancel out the milliequivalents here. See, these two are the same. This 1,000 milliliters over 36 milliequivalents is the same thing as this 36 milliequivalents for 1,000 milliliters. The reason why I flip it is because I want milliequivalents in the denominator here to cancel out with milliequivalents in the numerator here. So when I solve for that, I get 69.444 repeating. Right? Milliliters, the units are milliliters per hour. That's why I got this. And then the question, then you need to follow the instructions of the question. Numeric answer, no units or commas. Round final answer to nearest whole number. So around 69.4 repeating. Round to nearest whole number is 69. So the number you enter in the computer, 69, and hit enter. So if you have any questions, please leave it in the comments.